Hello everyone, welcome to Byte Nexus Tech. So as in previous video, we have watched the fundamental of C part 1. So I hope you have liked that video. So if haven't you watched, then you please go there and watch part 1. Then come to the next part, that is fundamental of C part 2. In today's video, we are going to cover that. So contents are variable, basic data types, type modifiers, format specifier, and type conversions. So, as in every video, we always go through some analogy and then we try to understand the concept in a better way. So, the analogy for today's video is, let's take we have a parking spot in our college. We have a parking spot. In this parking spot, there are some lots, different type of lots. This lot is for two-wheeler types. Okay, it is tagged. If two-wheeler type is there, then it that two-wheeler should go in this parking. Whose place will be, how much space it will occupy? Two-wheeler parking. Let's take 1 meter or 1 unit. Okay, like that we have four-wheeler parking here. This one is somewhat bigger, four-wheeler your car. Okay, if four-wheeler parking is there, it occupies, let's take a 4 unit, 4 meter or square or whatever it is, 4 unit it is occupying. So this is the four-wheeler type, and here we have again bigger space than anything else, that is eight-wheeler parking. So in this eight-wheeler parking type, it is, let's take it is 4 units, 4 meter square or 4 units space occupied. Whenever a new vehicles come, okay, vehicles come, so what happens? So before that, let's take, if we have given name to this parking space as A, to this parking space as B, to this parking space as C. So whenever new vehicle comes, what will happen? So whenever new vehicle means, let's take this bike is coming. Okay, I'm not good at drawing, guys, so please try to understand this in this way, that two-wheeler is coming now. If two-wheeler means that is the bike. Okay. If bike is coming, what compiler will see here? Compiler means your watchman. Okay. Watchman, what it will say that if bike is coming, this bike with the what type of it is? Two-wheeler, three-wheeler, four-wheeler, eight-wheeler. It is a two-wheeler. So bike value with two-wheeler, if it is coming, then it will ask it to park here in this, because its type is also two-wheeler, and so it will ask go and park here under the A block. Means wherever A has written, in that place you go and park your bike. So whenever car comes, so for car it is, car is, okay, car is four-wheeler type. So car will go here in this four-wheeler type by its name. Okay, if name is not mentioned, then how car will get parked there? Because car driver don't know which name location it need to park. So car will go and park under the B because it is a four-wheeler parking lot. Whenever a big truck comes, that big truck will be is a eight-wheeler type. Okay, truck is a eight-wheeler type, and if it is eight-wheeler type, we'll ask it to go eight-wheeler parking lot, which is a C block. So we will ask this truck to go and park at the C block. So through this analogy, what we'll understand that whenever what we understand that whatever the wheeler is there, okay, whatever the type of the wheeler is there, and the variable name means parking lot name. In this parking lot name, we are storing our vehicle. Okay, in the programming language, we say like, right, this is the type of the vehicle, type of the wheelers. This is the block where we are parking. This is the vehicle, our vehicle we are parking. So here in programming we write whatever the data type, what we are storing, we will be storing some data or some value. Okay, some value or some data we will be storing. So this we are storing into some named location. Okay, so named location will be there, that is we call as variable. And what type of variable value we are storing into this variable is defined by this type. This is data type. Okay, through this analogy we'll start with variables now. So now what are the variables? Variables are nothing but the named memory location. Okay, means we named a memory location when in the system, right? In the system there will be a physical memory, right? So in this physical memory, if I want to store something, then in this physical memory we we can store, right? We can store through the programming language. Okay, through the programming language, we can store any variable, any value we want to. But in this programming language, if I let's take I want to store age, that is 10, I want to store in the system. Am I able to store directly? Can I take this 10 and put somewhere? Right, it is not possible. So how can we store this 10 into the particular memory location? So this can be possible through the variables. Variables are the, we give the name to that particular location. Okay. So and by whatever name we are giving, by that name we will access, we will delete, we will do whatever calculation we want to perform on that. So to give the value, to store the value in particular named location, we use the variable, and in that variable we store. Okay, we have stored that 10 value at the named memory location A, that is 10 value. Okay, as we have stored, but how much memory it should take to store the 10 value? Okay, value 10, whatever we are storing. So that defined by the place, how much it should take is defined by the type we are using. Okay. So next we'll understand the type. So first topic completed, variables. Second topic is type, type of the data. Okay. What are the data types? Data types are nothing but the what kind of value we are storing into the variables. Okay, that is called as data type. Data type is nothing but data type, means what type of values we are storing, what type of values mean what type of data, what kind of data we are storing into our variable. If let's take, as if I am saying you age, if I am saying this to the brain, okay, our human brain is there here, one person. If I am saying what's your age, he will say my age is 25." How he is able to say? Because in his mind it is stored that if whenever it is asked age, it should be 25. Okay, so this 25 is stored in this, in his brain as a named memory, that is age variable, that is age. So in this age 25 it is stored in his brain. So in the same way system also store, so system also needs to store, right? If we are giving, if some form is there, okay, if some form is there and you want to fill that form, let's take application form is there, and if they ask you a age placeholder will be there, whatever you are putting that 25, it should be stored right from the form, it should be stored in the application. So to store in that application and to perform any operations with your variable, it needs this variable, right? Whatever, sorry, whatever operation you want to perform with your value, then how it is possible? Direct 25 I cannot send, right? Through some variable I need to send. So that is the variable we use here. And these variables we are using, then we also need to consider that what type of variable it is. Means Accordingly, we can put that like how much memory it can take. Let's take if age is there. Age is it is a whole number. Okay, so let's go to the next page and discuss about this. Let's check. For example, okay, before that I will give you all the basic data types. Okay, these are the data types and what are the different type of data type. First, we'll discuss that. There are three three types are there. So one is primitive data type. Okay, another one is derived data type. Third is user defined data type. Okay, so first is primitive, derived, user defined. In the primitive data type, we have primitive data types are nothing but these are the basic fundamental data types in which we can store a single value. Okay, derived data types are nothing but these are derived from the primitive, means from the basic data type. So we can store multiple values. These are the user defined. Name itself tells that this is defined by the user defined according to ease of requirement. Okay, how the requirement is there, accordingly we modify it to make that use means use we can use it, right? So first, primitive data types. There are many primitive data type. That is, one is integer. Okay, another one is float. Okay, then double, then char, then wide. Integer data type store the value. What type of value is stored into the variable? This integer data type, it stores only whole numbers. Okay, let's take your age is there. Age is whole number. Will you say that age will be my age is 25.3? No, we say just whole number. So in same way, we write its syntax as int, this which define this data type as we have discussed earlier. This is the data type int. Variable is the age, and in this we are storing 25. And always in C programming we end the statement with semicolon. So what will happen now? 25 will be, this value will be stored in this age variable, and it occupies only whatever this int data type is saying to occupy. How much memory it is asking to occupy, that much memory it will occupy. So for integer in C standard, we have 4 bytes of space allocated to this integer type variable, and it is always based on the compiler and architecture, but in general it is 4 byte. So for float, whenever we want to store some, like let's take decimal values, decimal values. Let's take a temperature I want to store. Temperature is 40.6 degrees Celsius. How can I store? I'll write the type. For that we have keyword, this float keyword, and whatever the temp is the now variable, in this temp variable store 40.6 degrees Celsius. No need to write Celsius degree, just 40.6. So this 40.6 is the decimal, but this decimal are less precisions. Means we are not giving so many, after the decimal we are not giving so many values. We are just giving less precised value. So less precised value if you are giving into some temporary temperature variable of type float, so float also stores the 4 byte of space for this. Okay. Now, when it comes to same, double is also same like float. It is also a decimal type, but it is more precise. More precise means more precision value. Let's take if I want to I have scientific calculator and I am performing some calculus related calculations. So at that time, how can I store that much big? Let's take value is 3.148325 something values, this much big values after decimal point, these many values. Will it be possible to store in the float? Not possible. Means every data type contains some range that we'll discuss later. So now to store that this much big scientific value, if we want to store in some variable, let's say I'm storing into the pi, then I should define its data type as double keyword. Okay, so this is the syntax for it. This semicolon I didn't give, sorry. So now we discussed it double, so it stores the 8 bytes. Okay, now when it comes to the char, char is nothing but character type. Character type means each character deals with single characters. Let's take a student wants to, I'll write here single character. Let's take students want to store his grades. Okay, his grade he want to store. So how can he store that? Let's take here grade is the variable. In this grade, I want to store a value. A is character type. It is not integer, float, or double. It is character, so I need to give a single quoted. Whenever character you want to store, you need to give single quoted, inverted. Okay. So end with semicolon. So a character goes into this grade of what type this variable is? Char type. Means char type of variable. So char type of variable contains only 1 byte of memory location to store this value into a grade variable. Now, when it comes to void is we mostly use it is just empty space. Okay, this is nothing but just whenever in the function we want to print something, so we use this void as a return type when no value to return. We don't want to return any value at that time, just we want to display something at that time, we use this return type, this void as return. So we don't need to worry much about this. We'll later on the next video we'll learn that one. So now I hope you understood these primitive data type. Now we'll go to understand the derived data types. So what are the derived data types? These are derived from the primitive basic, basic data types, and these are contain, we can store multiple values. So one is the array, such one data type is array. Another data type is pointers, and here in our C syllabus we always see function is also one of the derived data type. Okay, main is the array we need to discuss here. Important. Okay, what array is? Array is nothing but the arrangement. Okay, as I said, these are the derived data types. So array is also derived from the primitive data type. So let's take with some example, we will see if I want to put the ages. Okay, whatever the ages are there of the students, like all the age I want to put into a, a single variable. So what I will do, if I write here age 15, someone's age is 20, someone's age is 30, someone's age is 40. So these are the same, all are ages. So all the ages I want to put in a single variable so I can access. If I'm putting like this, if I'm in programming, if I'm saying int age equal to 15, int age 1, that is age 2 equal to 20, int age 3 equal to 30, int age 4 equal to, like, if single variables I am giving in programming language such individual variables, then it may take long time and the program will also be huge, and accessing those variable also becomes very difficult. So for that, in order to make this feasible for the programmers, what we have we have this array is where in single variable we can define as ages, and in that ages we can store same type of values one after another. Okay, this is the array. So what array is? This collection of same type of elements. Okay, either same type of elements or the same type of data, means same data types of items in this particular list. Okay, that is the arrays. So how we define array? Int, this arr is the variable name given to the array, and this uh, square brackets defines we are going to write the array. And if let's take, we have given size as 5, so 5 elements, 5 values of int type we can store here. Let's take 10, 20, 30, 40 and 50. So these are the int type of value. So each int means, as we discussed, that int will take 4 byte. So this is also taking 4 byte, 4 byte, 4 byte and 4 byte. Right. Each int variable is taking 4 bytes, these values, and in a same continuous memory location it will get stored. Not somewhere like if this much is a big memory, this is a physical memory, some value is stored here, some value is stored here. No, not like that. In a same continuous memory, continuous fashion, all those values will be stored in this array of type int. This is the array. Okay. Next we'll go to the pointers. In the what are the pointers? Let's take with the example. Let's understand it. If I am this is me, this Kumar, okay, and one person is there. There will be many person. Let's say P1, P2, okay. So let's understand with P1. So if I want the P1, so what I will do? Every time I cannot ask P1 to stay with me. Whenever I want to have whenever I want some help, then I will call this P1 for, and I'll ask him to do this help, and he will perform that task and I will release him. So for that I cannot uh, like put him with me. So what I will do, I have phone, smartphone. Okay, Kumar is very smart person. So what Kumar have? He has smartphone, and his smartphone, he has a contact number of P1 person. Okay, so what he will do, Kumar will just search his contact number, that is P1 person's contact number, and he will just call him, and he will call after he will ask him to help this, and after helping, after performing the task, he will ask him to go again back. Okay, so what's happening? Contact number, that phone number is pointing to that P1 person. Okay, so it means in this point phone number, the accessibility of person stays, right? So more precisely in our programming, we store the address of variable into this pointer. Let's say I have one int age equal to 50, and this is the variable as we have seen earlier, and this is the int type, and this 50 is the value. What if I don't want to use this age variable every time? I don't want to take it, okay, in the programming. So I just want, whenever I call by using something to this age, and I perform the operation and I'll release then. So for that you preferred use case, we use the pointer. So pointers looks like this, star p. So in this, I'll store the address of this variable age, of which type it is, also int type. Now what I did, I'll tell, whatever this age is there, this age is just a memory location. But is it the physical memory location that we are getting? No. If I want to access age means you can take the age directly variable. But I want to access the memory location of age, means dynamically memory I want to allocate or deallocate, whatever I want to perform, access the physical memory location. So its address is age is variable. So where somewhere this address will be stored, right? Let's take age is the variable, this is the memory location where 50 is the value stored. So age is also one of the named location. So this name will be also stored somewhere, right? So this will be, let's say its address is 1000, 10,000. Somewhere this age is also stored whose address will be, let's take 2000. So age is nothing but age just named, so its address is 10,000, so here 10,000 will be stored, right? So address of this age will be stored here as a 10,000 into the 2000 address. So these are the hexadecimal values. Just to understand, I written this 10,000, 20,000. So this 20,000 will be stored into one this pointer star p. Star p is just star means it is a precisely it is used to store the address of the variables. Okay, so if I write here p equal to address of age, then it will store that 20,000 whatever it is. And if I say star p equal to address of age, it will store that value 50. P means just we use this pointer for address storage, and star p we use to store the value at that address. Okay, in this way we understand these pointers, which are very important in learning our C programming. Next, we have functions. Functions are nothing but a block of code we use to perform certain task. Okay, this will understand it better in the next videos. Now we'll go to the user defined data types. So in user defined data type, as I said earlier, we have discussed this array. Array stores in the same type of elements. What if in real world, if a student's registration form is there, student form is there, and I want to store student's roll number. Okay, I want to say student's roll number, his age, sorry, not age. What we'll do, let's take, I want his percentage, and I want to store his grade also. Okay, so if I want to store roll number, percentage, grade, and many more things, how can I store these different types of, because roll number will be of integer type. Okay, and percentage will be of in points means decimal, it is floating type, float type. Grade is A grade, B grade, C grade, like it is a char type. So different data types of values, how can I store and how can I store and access through the a single variable, that is user defined data types variable, that is we call as structure. Structure is nothing but like in array we store multiple values, so this is a collection of elements. In array it is same type, in structure it is collection of element of different data type. Okay, different data types. So this is the structure. And structures syntax I can explain you. I can write here structures students. Okay, just I'm writing here enter role equals to, here also we can give the value, or next in the next while accessing we can give. This is a float, this is a percentage. I need to put commas, and here grade. Grade is of char type. Okay, you can put semicolon, or whenever we want to access we can access. This is just a pseudocode I wanted to make you understand this syntax. So later we have another one user defined data type, that is the union. Okay, union is also same as structure, but the difference is in the memory location access. Okay, so what union is, when in the like initial days of the C program, when initial days of the C programming, we had means in the 19s, somewhere like 40 year back, 50 year back, whatever it is. At that time, we have very limited resources, like limited system resources. Like memory will be also very limited. So at that time, like a structure, we cannot use all the memories, right? In Union, if we want, in means systems are limited, so we need to use Union. Why? Because structure saves, if one structure is there, S1, it saves its data type in different memory locations. But you, as we had limited systems at the initial days, so what in Union case, the same memory location, same memory is used, means same spot we are using for all the variable. Let's say age is there, char is the grade is there, and here roll number is there. These 4 bytes of memory occupy, this 1 byte of memory occupying, age is occupying 4 byte again. Okay, so as these are occupying the spaces, so what will happen in structure, it will save 414. In structures, it is storing total 9 bytes. Okay, this age, grade, roll number is 4 byte, 1 byte 5, 5 plus 4 9. So total 9 byte of memory it will allocate for this particular structure. But in union case, it will just occupy only 4 byte, means which is the bigger data type containing variable. This is the 4 byte, either age or this. Okay, sorry. Here we haven't used age. Here we have used a percentage, and this is percentages of a float. Okay. So what it will take, whatever the bigger data type size, this is 4 byte. So it will take 4 byte data type, and first when percentage comes, percentage will come here and perform its action and it will get released. Later grade will come of 1 byte, so it will perform its operation, it will go again. Then roll number will come here, roll number will perform its action, operation and it will get released. So at a time we can access only a single variable we can access in the union. So this is the union. We have third one is enum. We use rarely but important enough to understand this. Enum is the named constant. Like a best example is weekdays are there. Enum day. I want to store the days in a like readable for programmer, like Sunday, Monday, Tuesday, okay, and fixed index will be assigned to is 0, 1, 2 in programming. Means in compiler it will be by default these constants values, integer constant values. So in programming we can use just a Sunday, Monday, Tuesday like that as a weekdays, and accordingly the integer index will be assigned to it, and that will be easy for human readability. Okay, easy for human readability. So that was for data types we have covered so far now. So now we'll go to the next topic, that is type modifiers. Okay, here type modifiers. Type modifiers are nothing but these are the, let's take we know means type modifiers are used for modifies the, first we'll understand its definition. Okay, modifies the size or the range of type, means data type. Okay, so modifiers modifies the size or range of the type, means this data type. Let's take, I have as I said that it will modify the size. First we'll see what are those type modifiers. Short and long, for this is for size, and for range we have unsigned and signed. Okay, short means whenever we want to, let's say for first understand this one. First understand this how bytes work. Okay, each byte contains the 8 bits, means from 0 to 7. So as we know these bytes and all, we consider it in binary. So 1 2 3 4 5 6 7 8. Okay, this is the 8. So 8 bits accumulate to form a 1 byte, and it is from 2 power 0, 2 power 1, 2 power 2 till 2 power 7. Okay, so how much it will? So 1 byte is nothing but this 128 bit. Okay, sorry, not 128 bits, it's a 128 binary. This is the size. Okay, so if one is short, so for the short we define 2 bytes. For long, if it is int, okay, if it is int, so if it is int, I'll write here down as example. Let's short int a equals to 20. If I write, so 20 is the whole number in the a variable we are showing of int type. But what I'm saying, modify its size to short. Short means it will modify this int to it was before 4 byte. When we write short means modify its range to 2 byte now. Okay, like that it is used. And if I say long int, some ranges will be there. That ranges you can later, you can if you want online you can search and you will get, and those ranges are not that much important, so that's why I'm not writing here. So long int a equal to 20, if I write, then this 20 will be stored of integer a type. But if I write here long as type modifier, then it will modify this type from 4 byte to 8 bytes. Okay, so why these all we are doing? We are doing whenever we want to store a large value. Let's take this 20 in short into your storing. If it is like this values, okay, 20 lakhs values is there. How can you store that 20 lakh values? Not possible, right? So we need to define this type modifier to store that values. So some ranges are there to store that value, and that ranges we calculate based on uh, this given bits and bytes. Later we'll come to the signed and unsigned. Okay, unsigned means all are positives. Signed means both positive and negative. So by default it will be a signed only. If I want to define only positive values, at that time what I can do, I can write here unsigned int a equals to 5000 or whatever it is. So it means only positive values can be stored here in the unsigned int. Okay. So if I write signed, then both positive and negative, which is by default. So these are the type modifiers we understood now. And after that, we'll go to the next topic, that is format specifier. So in this format specifier, what are the format specifier? First, we'll understand that. Okay, format specifier means it will just format, specifically format the whatever you want to perform, means whatever you want to show or take the input, the output, or take the input. For that it will define the format of that particular variable or the types. Okay, so format specifier, let's say first understand when we want to take the input from this user, right? This is the system, and always it take the input from the user and give the output to the results to the user, right, back. So input, if we want to take in programming, we have special function, that is scanf. If we have this scanf, if we define, which we have discussed in first video, from the header files it will take. So scanf means, scan means scan the input, f means format that in this way. If I want to take the age, then what I will do, I'll do like this. percentage d and age. Now I'll make you understand this first. Scanf, scan, and after scanning, before that I'll write here this variable I need to define int age. Okay, this int age, I didn't assign the values yet. I just defined one variable age of type int. Later, I want to take the value. I don't want to assign here it hard-coded value. I want to take from the user. So at that time, I'll write scanf percentage d address of age. Means age is just a variable name or named. Okay, named to somewhere some variable. Sorry, some memory location. I don't know which memory location it is. So what scanf function will do? Scanf function will take that age value, what user is putting. Let's user is putting 50. So that 50 value control is going into the age address. At this ampersand this ampersand define the address. Okay, ampersand is nothing but in programming this is the address. So what control is saying, whatever the 50 values is coming from the user, go and put at the address of this age location, age named label. So address of the this age label is the this one, address of this age label is this one. So in this value this 50 will be stored, and for this is the integer type value we are taking. So for that we have specified format specifier as we can say percentage %d. So in the same way, if I want to print the value, how can I print percentage %d? I can say just age. So in this percentage, whatever we are putting value, what type of value we are putting, giving as output? 50. Let's take 50. So 50 is integer type, so percentage d, and as it is age value. This is the age means value, and address means the memory address location. Okay, so both the things I hope you have understood now. Let's take with more example, int, float, double, character, and after that we have character. Okay, so int, for int we have format specifier as percentage %d, for float we have percentage %f, for double we have percentage %lf, for char we have percentage %c, and for string also we'll learn that later, that is percentage %s. As we are moving forward, we'll learn those advanced concepts as well. Okay, these are the format specifier we use. By putting this into this scanf and printf, we define the format. Okay, I hope you have understood this one. Now we will directly go to the type. So fifth topic is, that is the type conversion here. Okay, fifth topic is type conversion. What do you mean by, guys? By the name itself we can understand it converts the types. Okay, one data type to another data type. Okay, it will convert. That is called as type conversion. There are two ways. One is implicit type conversion. Okay, another one is explicit type conversion. Okay, what do you mean by this is, first, what will happen? Let's say I'll give this. First of all, I would like to make you understand this. What's the implicit type conversion? The main, I'll give you one note that this is the type conversion promotion rule, we can say in this note. Whenever each type conversion has happening from one type to another, it will be always from lower data type to higher data type. Lower means in size, I'm saying. Okay, so the lower data type is the char, okay, which is 1 byte. Then after that integer will come. Okay, after that float will come, and after that double will come. Okay, so this is the promotion rule, how type conversion will happen in implicitly. Implicit means it will automatically type conversion will happen by compiler. Okay. And explicit type means manually when user does this conversion. Okay. Like this is also called as type casting. We are casting, user is casting the type, means converting the type. So this what promotion rule says, whenever this is from lower data types to higher data types, when we promote implicitly, that is called implicit type, which is automatically does by compiler. This is 4 byte, this is also 4 byte, this is also 8 byte. Okay. Now the question rises, if both are of same size, okay, both are 4 byte, then why promotion rule is pointing from lower this int to float? Means int value will be, let's take if any int value is 8, okay, and the float value is if 8 is the int, in float what it will be, 8.0. Okay, converting this 8 into 8.0 is implicitly done, because this 8 is the integer value and this 8.0 is the precised. After decimal it is 0, so it is a precised value, so always implicit will work like this. But what if I want to convert 8.0 to 8, which is explicitly we need to do? Okay, so we will first understand the what do you call, we need to understand the analogy. So, and this in implicit I would like to mention that it is a safe, because it does by compile, it is safe. Explicitly when we are doing, sometimes data loss will happen. Okay, now not sometime, every time data loss will happen whenever we are doing explicitly. So by considering this use case, we need to move further, right? So in the next page I will explain you the one example for implicit. So what happens, let's take int a equal to 8 is there, okay, and int b equal to 20 is there, right? So what if I want to calculate int result, okay, by a plus b, what will happen? 8 plus 20, it will be 28, and it will print the 28. As this value is integer, we are storing in int type of result variable. Okay, so it will happen. Now when it comes to, if int a is 8, and I'll take another here example for you to understand. Int a equal to 8, what if this b is a float? Okay, let's take it is 20.8, okay, something whatever it is. So now what will happen? Now when a result, okay, whatever the result we are storing into it, what will happen? A plus b means, what compiler will do, compiler will understand it, int a, so it will put a. What about float b? B is there, b means 20.8. Now compiler will see this is the float value, okay, this is the int value. So converting this int value into float, it is implicitly it can be done, and there is no data loss in this. It is very safe to do. So what it will do, it will make 8.0 and 20.8 internally. It does by compiler. So 8 and 20, 20.0 plus 8, 8. So 20.8 it will give, and it will be stored into this float result. So it will be stored as 20.8. So what it did, it the main logic it did is it converted the integer value into the float implicitly, as the requirement was, means as the one of the variable was of float data type. Means whenever, if let's take we have we are calculating some distance, and in distance one is, let's take 1200 meters, and one distance is, it's 2 kilometers. So Can we able to compare this? No, I need to convert at least one type means uh, okay, one type to another type. Means one measurement I need to convert to another measurement. So then only we can compare them if they are in same line. If I'm saying this is kilometer, this unit is kilometer, and this unit is meter. So can I able to compare? No. So what I will do, this whatever lower unit is there, I will convert into higher unit. So it will become 1.2 kilometer distance one. I hope you guys know this 1 kilometer equal to 1000 meters. So same this also uh, 2 kilometer. Then we can compare. So both are in same unit. So 1.2 and 2 we can compare like this. So in this way implicitly it can be done like this. I hope you understood implicit conversion. Now we'll go to the explicit conversion. Explicit conversion user will do. Okay, how user will do means, let's take I have the int a equal to 50. Sorry, just missed. Let me erase it now. Okay, now int a equals to, let's take 50 I have written, and int b equals to, let's take 20 I have written. Okay, now what I want to do is I want to print division. Okay, I want to calculate the division of it. So if I calculate the division of it directly, it both are int. So what will happen? 50 divided by 2. If I write, then what's the answer? The answer will be, if both are int, then answer is 2. Okay, 2 the 20 to the 40. So answer will be 2 only. It won't give as 2.5. Why it won't give? Because these both are integer. As if both are integer, then it will, this integer value will be 2 and 2 will be stored into this division. Okay, even if you write here float, then also division value will be 2.0. So can you able to see there is a loss of data, right? So in order to not happen this loss of data, then what we need to explicitly, we need to write here as this was the before typecasting. Okay, this is the before typecasting. Now this one is the after the typecasting. After the typecasting, what we will do, whatever this float division we are assigning our result it to, 50 is there, that is a value, okay, divided by b value is there. What I will write before that, here I will write typecast as float. So what will happen, integer will convert into float. Now in the compiler what it does, a is converted to float, so 50.0. Now explicitly it is typecasted, divided by 20. So compiler what it will think internally, 50.0 divided by, implicitly again it will convert 20 also. So 20.0. So if both are in decimals, then answer will be 2.5. So it will give division as 2.5. So in this way this type conversion works. And another example also I can write here just to understand you better. For char we can write, okay, if char c equals to a is there and char is 1 byte, I can convert it to higher byte, that is int a equals to, I can write c. This implicitly it will gives the 65. But if I want to convert this ASCII 65 value to A, then what I need to do is I need to say char C equals to, okay, I need to explicitly typecast it to char this 65. If I do, so 65 is the integer value. I'm converting this integer value to char. So character in ASCII it will convert as this ASCII value, it will consider it as ASCII value and it will convert into a character and it will assign. So in this way this type conversion work. I hope you have understood this is full basic fundamental of part 2. So please guys comment, subscribe and like the videos. So it should reach to everyone who are excited to learn programming. Thank you for watching this video.